So as mentioned in the email this video is attached to, a sports car starting at rest achieves 30 meters per second in 4.7 seconds according to advertisements. And the figure that is written below, that shows data for v sub x as a function of the time as a sports car starts from rest and travels in a straight line in the positive x direction. Part A is asking, what is the average acceleration of the sports car from 0 to 30 meters per second? Part B is, what is the maximum acceleration of the car? And part C is, if the car has a displacement of 750 meters from t equals 0 to t equals 19.1 seconds, what is the car's average velocity during the entire 19.1 second time interval? Well, the first thing I have written on here is the chart that was mentioned in the question. It shows the car traveling, and all the data points are right here in this little table. But to find the average acceleration, the change in velocity for the time interval is going to be divided by the time interval. And then to find the instantaneous acceleration, it's just a slope of the velocity graph. So it is the maximum where the graph is steepest. And at that point, the velocity is changing at a high rate. So we do expect the maximum acceleration to take place early on because the magnitude of the acceleration must decrease as the velocity gets higher and higher. So there is a maximum velocity for the car after all. First I wrote down what I need to find, which is the acceleration average, for v sub x during the 0 to 30 meters per second. And then for the question B, we need to find the maximum value of the x acceleration. And then for part C, we need to find the change, or for part C, we need to find the velocity average in the x from t equals 0 to 19.1 seconds. So back to solving part A. The car starts from rest, so the x initial velocity is going to be 0. And then it reaches v sub x at 30 meters per second at a time of 4.9 seconds, according to the data table. So using this time interval, we can find this value by using the equation of A average acceleration in the x direction is equal to the change in v sub x divided by the change in time. And all I did was put my values in for that, and I get that it's 6.1 meters per second squared. So the average acceleration for this time interval is 6.1 meters per second squared in the positive x direction. Now for B, the acceleration component of AX at an instant of time is the slope of the tangent line to the v sub x times t graph that I have written up there at the time. Find the maximum acceleration we took for the steepest part of the graph. So in this case, the largest slope occurs near t equals 0, just as a car is starting out. And I have drawn a tangent line up here to illustrate this. To show that it passes at t equals 0 and it passes through t equals 0. Values for the rise and the run to calculate the slope of the tangent line are read from the graph. So the tangent line passes through the 2 points of t equals 0, comma vx is equal to 0, and it also passes through t equals 6.0 seconds, and v sub x is equal to 55 meters per second on the graph. So the rise is going to be 55 meters per second and with a run of 6.0 seconds. So the slope of the line is going to be equal to this equation here, which is a sub x is equal to 55 meters per second minus 0 meters per second divided by 6 seconds minus 0 seconds is equal to positive 9.2 meters per second squared. So the maximum acceleration is 9.2 meters per second squared in the positive x direction. And now to find part C, since we already know the displacement, all we do is put that over our time interval. So we use the equation of v average in the x direction is equal to the change in x divided by the change in e, which is again equal to 750 meters divided by 19.1 seconds. So it is 39 meters per second.